Hello everyone, and welcome to another episode of Cosmic Adventures, where we explore the wonders and mysteries of the universe. I'm your host, and today we're going to talk about one of the most fascinating and powerful objects in the cosmos, black holes. What are black holes? How do they form? Why are they important to study? And could we ever use them for interstellar travel? These are some of the questions that we will try to answer in this video. So buckle up and let's dive into the dark and mysterious world of black holes. Black holes are regions of space where gravity is so strong that nothing, not even light, can escape. This means that black holes are invisible to our eyes and telescopes. So how do we know they exist? Well, there are two main ways to detect black holes: by their effects on their surroundings and by their gravitational waves. The first way is to observe how black holes affect the matter and light around them. For example, some black holes have a disk of gas and dust swirling around them, called an accretion disk. This disk is heated up by the intense gravity and friction and emits radiation that we can detect. Sometimes, the black hole also shoots out powerful jets of particles and energy from its poles, called relativistic jets. These jets can be seen across the electromagnetic spectrum, from radio waves to gamma rays. Another example is to observe how black holes bend and distort the light from distant stars or galaxies behind them, creating a phenomenon called gravitational lensing. This is like looking through a magnifying glass and seeing a distorted or amplified image of the object behind it. Gravitational lensing can reveal the presence and mass of a black hole, and sometimes even create multiple images of the same object. The second way to detect black holes is to measure their gravitational waves. Gravitational waves are ripples in the fabric of space and time, caused by the acceleration of massive objects. When two black holes orbit each other and eventually merge, they produce a burst of gravitational waves that can be detected by special instruments on Earth, such as LIGO and Virgo. Gravitational waves can tell us the masses, spins, and locations of the black holes, and also confirm Einstein's theory of general relativity. Now that we know how to detect black holes, let's see what happens inside them. Imagine you are a brave astronaut who decides to venture near a black hole. What would you experience? As you approach the black hole, you would notice that the light from the stars behind it becomes distorted and stretched due to the gravitational lensing effect. You would also see a dark circle in the sky, surrounded by a bright ring of light. This is the black hole's event horizon, the point of no return. Once you cross it, you can never escape. As you get closer to the event horizon, you would feel a strong tidal force pulling you apart. This is because the gravity of the black hole is not uniform, but varies with distance. The side of you that is closer to the black hole feels a stronger pull than the side that is farther away. This difference in force stretches you out, like a piece of spaghetti. This is called spaghettification, and it is not a pleasant way to go, but let's say you somehow survive the spaghettification and cross the event horizon. What then? Well, no one knows for sure because the laws of physics break down inside a black hole. But according to some theories, you would encounter a singularity, a point of infinite density and zero volume, where all the matter and energy of the black hole is concentrated. The singularity is a mystery and perhaps the ultimate paradox of nature. Some people have speculated that there might be a way to avoid the singularity and enter a wormhole, a shortcut through space and time that could lead you to another place or time in the universe, or even to another universe altogether. This is a very intriguing idea, but there is no evidence or proof that such wormholes exist or that they are stable enough to travel through. So don't get your hopes up too high. Finally, Let's see if we could use black holes for interstellar travel. Black holes are not only fascinating, but also potentially useful for our future. They could provide us with a source of energy, a way to test our theories of physics, and a means to explore the cosmos. One possible way to use black holes for interstellar travel is to harness their rotational energy, or spin. Some black holes spin very fast and create a region of space around them, called the ergosphere, where everything, including light, is dragged along by the spin. If we could somehow place a spacecraft near the edge of the ergosphere and fire a rocket in the opposite direction of the spin, we could gain a lot of energy and speed from the black hole and escape to a faraway destination. This is called the Penrose process, and it could theoretically allow us to travel faster than light. Another possible way to use black holes for interstellar travel is to exploit their gravitational slingshot effect, or gravity assist. This is a technique that we already use to send probes and satellites to different planets and asteroids in our solar system. By using the gravity of a planet to boost or change the speed and direction of the spacecraft. If we could do the same with a black hole, we could achieve even greater speeds and distances and reach the outer edges of our galaxy or beyond. Of course, these are just hypothetical scenarios, and there are many challenges and risks involved in using black holes for interstellar travel. For one thing, we would need to find a suitable black hole that is not too far away, not too massive, and not too dangerous. For another thing, we would need to design a spacecraft that can withstand the extreme conditions near a black hole, such as the intense gravity, radiation, and time dilation. And finally, we would need to consider the ethical and moral implications of such a journey, such as the impact on our planet, our society, and ourselves. So what have we learned today? We have learned that black holes are the most mysterious and powerful objects in the universe, that they can be detected by their effects on their surroundings and their gravitational waves, that they have a point of no return called the event horizon and a point of no sense called the singularity, and that they could potentially be used for interstellar travel if we are brave and clever enough. Black holes are the ultimate frontier of our exploration of the cosmos. They challenge our imagination and our understanding of reality. They may hold the secrets to the origin and destiny of our universe, and they may also offer us a chance to see and experience things that we never dreamed of. Thank you for watching this video, and I hope you enjoyed it. If you did, please like, share, and subscribe to my channel. Until next time, keep exploring and stay curious.